Okay, now let's take these ideas of angular measure and apply those to velocity, which is more of you know, an application. So we're going to talk about linear velocity and angular velocity and how those two are related to each other. Linear velocity is something that you're probably already familiar with. Linear velocity we think of in terms of speed, and it's defined by distance per unit time. So if you look at this equation down below, you can see velocity uh, is distance per unit time. Now, if you look at this car, okay, the distance that the car is traveling it's a straight distance, or it is a linear distance. So it starts someplace here, which might be at time zero. It goes a certain distance, and then it's at a different place at another time. So maybe time being equal to 1 second. Okay. This is typically, what we think about as we're walking around or if we're driving in a car or a bus or a train or even an airplane. And, speed, we think of if we're in a car or plane or a train in miles per hour. We have a unit of distance over a unit of time. But instead of this unit of distance being a linear distance, what if the distance was curved? What if the distance was the distance around the curvature of a wheel? So for example, this car, it's got a wheel here in the front. So let's pretend we had the wheel of that car, and let's mark two places. One place we'll mark right here. That's where the tire is positioned at this point on this linear distance. And we'll make another mark on the opposite side in green, okay, to show this distance around the tire. Okay, that would be the arc length. Now, as the tire rolls forward, as it rolls forward, it will be at this position. And as it rolls forward, this mark on the tire will come forward until it makes contact with the road. And the other side of the tire will be where it was. So you can see that as the tire has gone linearly in this distance, we've covered this distance around the arc of the tire, the arc length. So we could think of distance as being equivalent to arc length. So we use the letter S to denote arc length and the letter D to denote distance. Those are the same lengths, okay, except one is linear and the other one is curved, but they're the same length. So if we take this same formula for linear velocity and we start to wrap it around the tire, then instead of D, which represents a linear distance, we use S, which denotes an arc length, which is a distance around the circumference of the tire. And you can see we still have the same formula. It's just that the letter for distance has changed from a D to an S to denote a difference in the context of the distance that we're actually measuring. And, the distance around the outside of the tire, right, that is going to be part of the circumference. And their circumference, will be measured also in terms of length, which could be miles, meters, inches, or centimeters, and still units of time, such as hours, minutes, and seconds. Okay, so we can think of linear velocity, okay, in terms of a distance being a linear distance or that being curved. Now, let's think about angular velocity. So instead of thinking about distance per unit time, what if it was the rotation angle per unit time? So that would be what we call angular velocity. So instead of measuring the distance that the tire has rotated, now we think of the angle that the tire has rotated. And we could then write a similar formula. This is for angular rotation as the number of degrees or radians per unit time. So degrees or radians per unit of time. So that's angular rotation or angular velocity. Now, linear velocity is related to angular velocity by the radius of the angle of rotation. So it's directly related. So linear velocity is equal to angular velocity times the radius of the angle of rotation. But notice for this relationship to exist, angular velocity has to be measured in radians. So even though you could express angular velocity in degrees or radians, if you wanted to compare linear velocity to angular velocity, actually not compare, if you wanted to do a conversion, then angular velocity has to be in radians and not degrees. Okay, so this is a abstract 30,000-foot view of linear velocity and angular velocity. Next, we'll look at some examples to see how this works in practice. Let me know if you have any questions.